You, Jim.
Yes, I'm the author of two books on the electric vehicle, and the space is now evolving so rapidly. We have to keep very close tabs on it at how we're moving ahead. I think we have a very exciting panel here. We have Udo Panenka, who's president of ATS Industrial Automation. We have Robert Lane, who's the founder of Manaflex, and Martin Starkey, who's the managing director of Ricardo's Performance Global Division. And what we're basically looking at in this panel is a situation where the EV market is growing very rapidly internationally. There was maybe 3 million electric vehicles sold in 2020, but we're talking about as many as 12 million by 2025 and maybe 31 million in 2030. And the question is, will the battery space, do we have the capacity, and will we be able to meet the challenge of providing batteries for all those cars, battery packs and modules for the incredible demand? And every day there's a new announcement of electric vehicle launches, and all the automakers are talking about no longer producing internal combustion. We just heard that the European Union is talking about banning all gas and diesel vehicles by 2035. That's pretty dramatic. There were already such laws on the books in various states in the US and in European countries, and indeed all over the world, in Asia too. So are we going to be ready? Let's just have introductions from each of our speakers. Udo, do you want to start?
Absolutely. I believe we will not be ready, but let's start with the introduction. My name is Udo Panenka. As Jim already said, I'm the president of ATS Industrial Automation, part of the ATS Group, which was actually one of the largest automation players here around the globe, with a little bit more than 5,000 associates. To us in ATS Industrial Automation, e-mobility is a key strategic market. And when we talk about e-mobility, it's mainly battery assembly and fuel cell assembly and testing for both of them. I've delivered more than 70 projects here over the last 20 years. And if I look at me personally, I've been working for the last 13 plus years for companies with a strong lean focus. And I've been looking here at how the auto industry is driving the transformation towards greener transportation. And I can see an incredible amount of what we call in lean muda, or waste here, within this entire process. So to me, I have a dramatic passion here for working together with our partners, our OEMs and their suppliers, and really finding better and disruptive ways to help facilitate this transformation. Thank you, Jim.
The idea that there will not be enough battery capacity is a fairly dramatic thing, and we're going to focus on that pretty much in the panel. It's something that we have to address and have to be ready if we're going to actually make this transition to all electric vehicles. Robert Lane, you want to tell us about yourself a little bit and your perspective? You're out there in Hawaii, right?
Yes, I'm over on the Big Island. Yes, I worked at, I started my career at Lockheed Martin, but I focused a lot on weather satellites and things related to environmental technologies, and then started to realize that, you know, making a big change needed to be focused on materials and on solar, battery, those types of things. So started getting into solar, and then worked on solar arrays, and then got into battery technologies, where I went into Tesla right after IPO. Worked there for 7 years on different projects, Model S, and then Model 3, and led the Tesla energy design for Powerwall 2. So have a fair bit of experiences working in batteries from early days, and decided there's a lot of big holes in the, you know, ability to make batteries at scale. And so one of those was the interconnecting components. And so started my own company and partnered up with some suppliers and engineers, and we decided to just go for it and started a company called Manaflex.
Okay, Martin, and of course, I should just mention that Tesla's solution is to build its own battery factories, but it is only basic. It's not building cells yet. It is largely doing packs and modules and stuff like that, and it's still dependent on suppliers for battery cells. Martin Starkey, tell us about yourself.
Yeah, sure. Thanks, Jim. So as Jim mentioned, I'm the managing director of Ricardo Performance Products. Ricardo's a well-known and well-respected engineering and manufacturing firm. For over 100 years, been developing solutions in automated powertrain technology. Obviously, for the majority of that, it revolved around combustion engines and multi-speed transmissions, and in more recent times have evolved into a very different offering around supporting the electrification journey. So the products that once upon a time we were producing, fire-breathing V8s for sports cars, we're now looking at power-dense battery systems, or where once upon a time it was 8-speed DCTs, we're now looking at sort of super efficient, super lightweight, single-speed e-axles, and amongst our great portfolio of products, we're doing things like Formula E, the current World Championship team use a product from us. So really exciting journey we're on, and we're looking at how we help make Udo's prediction at least slightly wrong, that some of that capacity is there, especially in the niche volume area. So thanks, Jim, and thanks for the introduction.
Great. I'm just going to remind people who are watching this at home, you can ask questions by clicking on the Q&A button, and we'll take a look at those going forward. And I'm going to ask questions of our specific panelists, but then others will be able to chime in on the question. And we might as well start with Udo, and really what is sort of the overarching question here, which is what are some of the challenges with EV battery production capacity and being able to meet all the announcements that have been made?
Yeah, I think that's definitely the elephant in the room here from my perspective. And if I step back here, I think there is, on the one side, to me, I call this the magic triangle, and then there are some underlying issues. So, sorry, the magic triangle to me is that battery technology that is improving at a dramatically rapid pace. So we're not yet having stable products. There is a lot of technology that is still evolving, that affects the range of the car, that affects the charging of the car, that affects the cost of the battery. So costs are still dropping in the 10+% range a year. So that battery is not stable, it's evolving rapidly. And at the same time, if I look at many of the automation projects in the industry, these automation projects, building a battery assembly line, a module and pack assembly line, that takes everything between 2 and 3 years here, from the RFP, request for proposal, to the full production ramp up. While the other piece is these automated assembly lines, the way how they're designed today, the way how they're driven today, basically these lines cannot be easily and flexibly adjusted here to new battery designs. And if you take these three factors together, this is already, call it, some kind of a setup for failure, why we believe many of today's projects are not working as smooth as they should be.
It's rather alarming what you're saying, and it's kind of a wake-up call you're delivering to the industry. Robert, do you want to comment on that? Do you have thoughts on whether we're sort of approaching going over a cliff here with battery delivery?
Certainly, I think we have gone over a cliff locally because of COVID. The cell shortage is quite difficult to deal with, but I do think that it's going to catch up very fast because there's a lot of attention on this. When you have a battery, you have thousands of cells, whether it's cylindrical, prismatic, or pouch, and so dealing with those cells is complicated. There's very high precision tolerances where you have to place the cells, and then how do you interconnect those cells? That's a challenge that you see every day, and it's just one of those things where you need to really be cognizant of keeping it simple and addressing, you know, every single design choice very carefully, with the battery being up front, right? We have to think about the battery up front. And so it's very important also that, you know, our reliability is thought of, because it's not like we have one cell go out and, you know, it's won over the entire number of cells in a battery. It's multiplied by the number of in series bricks. So when you reach that full capacity in a brick, it's going to limit the other bricks. And so your percentage can be upwards of 1, 2, and as the cells get bigger with less parallel cell counts, the percentages increase in terms of your capacity fade as you don't do that cell interconnect correctly. So there's a lot of attention right now on how do we interconnect the cell super reliably, super fast, you know, and so you want to choose equipment that's just really high, you know, good quality, people who know what they're doing. They've been doing it for a while and have proven track record, and coupled with really compelling new technologies that can enable this market.
Martin, do you want to get in on that? Just looking at that big picture question, are we facing a supply problem?
I think we are, Jim, and I was just going to step back a little bit and strategically, I think one of the really big challenges here, if we look where battery technology came from, you know, things like laptops, let's take it, you know, huge consumer of battery cells. That was a product that had a relatively short life. You know, the next generation laptop would come along, you could introduce a new cell relatively easily. You know, it was a rapid turning market. If we look at automotive, you know, it's very different. It's a very mature market, very systems driven for all the right reasons. You know, they want to bring a quality assured, well-developed product to market because the consumers demand it. It's an expensive investment. And you're trying to mesh it with a equally massive industry that's been all around innovation, new products constantly coming to market in terms of the battery cells themselves. And just to give you one interesting challenge I've seen derail a number of projects is, you know, the automotive industry demands, you know, you need to supply me my product for my 5 years of production and then 15 years of spares afterwards. You go to a cell manufacturer and say, brilliant, this is the product for us that's literally just come to market. We want to qualify it in for 5 years, and then you need to sell it to me for another 15 years after that. So they're saying, right, so I've got to keep this cell in production for 20 years. That's right. You go back and ask Toshiba for an OEM 2001 battery for your laptop. I suspect they'll politely decline to offer you those spares. So I think there's some really interesting challenges in meshing very different industries together to bring the solution to the market.
Definitely an interesting time. And Robert, let's ask you this question. What makes automated battery module and pack assembly and testing solutions so difficult? And why do so many projects fail?
So a lot of times, I know, like, when you're a battery designer is going to go about designing a battery for OEM specs. And so OEM will ask, you know, all kinds of requirements that, you know, are important to the OEM, but when you think about a battery, you really need to think about what is it that the battery needs to be optimized, and so I think that's where the biggest problem occurs the first, and then as you get into battery design and battery manufacturing, you learn that, and then there's a feedback cycle there. So that feedback cycle might take 2-3 times before you understand as a company that, you know, it's important to look at the battery requirements and put those up front. And there is some compromise, of course, but still you can't make amorphous shaped battery modules and every single battery module is a different shape and then puzzle piece them together. That can create some difficult challenges. So that's a big deal. And there's a lot of other important form factor design choices that need to be made as well to enable, you know, automated assembly. We're going into this revolution in AI and automation, And it's super important that we go through it, very step by step, simply to enable so that we can be successful at it. And that will enable us to make these larger modules at scale.
Do you accept the basic premise of the question, which is that a lot of projects fail?
Yes. I think all projects fail, but it really depends on how you react to the failures. That matters the most.
Whether you learn from them or not, basically, I guess.
Yes, whether you learn and whether you can go through that cycle quickly, and get ahead of it and change the design appropriately fast enough. And so you need your automation line to be very flexible as your designs will change. They evolve rapidly. We go through multiple cycles, like there's alpha, beta, C, D phase to production, and you have that chance to loop it. But I always see multiple changes within a phase, especially with batteries. And one of the reasons is because of the design. You think of all these design requirements. You have all your interconnects laid out. You have your cooling system. It seems all perfect, and then you get to the end, and then you do your thermal testing, your thermal event testing, and then something really bad happens, and you have to do another cycle, and you have to go do it all over again. And that's just the nature of new technologies, and especially power electronic technologies with such high energy densities today.
Udo, do you want to address this question, this automation question also?
Yeah, and possibly go a little bit into connecting what Robert said here by saying connecting all the pieces and the cells in a battery, just to give you a little bit of an idea of what we're really talking about here. Many of the battery packs, they have possibly something around 6,500 cylindrical cells. If you take cylindrical cells, that means 13,000 weld contacts. And if only one of these welds are damaged, the range of your vehicle drops by 1.7%. So that shows a little bit that importance of processes, but it also goes more into what Robert said, lacking standards, a lot of variations. So if you combine these challenging processes with lacking standards, then you're getting into quite some challenges. You touched on the aggressive goals in the beginning here, Jim. Basically, the race is on. Almost every day, another CEO comes up and talks about a more aggressive plan and spends more money on electrification and shorter timelines and shorter ban of ICE cars. And I think it's fair to say that this entire industry is still on a real learning curve. It's different to be in the old powertrain world where you have people that have done this for so many decades, basically. When you think about that whole learning curve in battery technology, for the OEMs, for their suppliers, for the automation companies, there is still a heck of a lot of dynamic in this. So I think that combination, what the teams have said here, that really is what it makes quite challenging to set automation up in a proper way.
Martin, would you like to comment also?
Yeah, I think really very quickly, just to expand on a point Udo put there, I think about, every day there's a new entrant. I think with an electric vehicle compared to maybe a gasoline type car, actually in some respects is a lot simpler in terms of the powertrain, certainly, which makes it a lower barrier to entry to bring a new vehicle to market. And I think history will look back and judge just what a dramatic effect, and we'll use Tesla as a great example, these new entrants had on the business model. I think had it relied on the classic established OEMs, this electrification journey in some respects would have been easier. It would have been much slower, but it would have been easier because it would have been a controlled introduction. They all have similar processes. They all have similar sort of validation and development plans. I think it's these entrants that have come in, they've really shaken it up and said, well, that's okay, we'll just skip, we'll go straight from alpha to gamma, and we'll shortcut some of the validation work, and we'll get a product out there that will leapfrog our competition, and they're entirely entitled to do that. But I think it really has stirred up and created this additional challenge on the market to bring these projects to realization.
Well, obviously the automakers have had to admit they didn't know a whole lot about batteries, and that meant they had to create a whole lot of partnerships with companies, and some of those companies don't work the same way the OEMs do. There's been culture clashes that way. But let me just stick with you, Martin, and ask, what needs to change to make sure that we don't fall off this cliff? We're talking about this mythical cliff with OEMs and their suppliers to build better batteries and make sure all the technology that needs to be there is there.
Yeah, I should probably caveat my answer with the fact that I consider myself one of those tier ones that wants to work with the OEM. So that may skew what I'm about to say, Jim. But I think you need to approach this differently to the classic OEM sourcing. You know, this isn't going to be answered effectively necessarily through a well-structured RFQ. This is about partnerships, communication, longer term planning, because you need the tier ones to bring flexibility, because you're going to introduce flexibility, back to Udo's and Robert's point, through the development of the battery, because a new technology is going to come in at the 11th hour, a new chemistry, a new cell. You're going to want to jump on that. And what you don't want is a supplier at that point that's going to say, well, let me look at my contract and, oh yeah, I can PVR your project on this. And you want far more collaborative, partnership-driven solutions, at least for the next 10, 20 years, because you're going to need your suppliers to help you out. So I think that is the most important bit in the short to medium term. Don't treat it as a classic sourcing exercise. This is something very different.
I was just thinking of an example of this kind of cultural clash, and it was when the automakers introduced Apple CarPlay, and they tried to have a very fixed schedule for when it would be available, and they made all these announcements, but Apple was not on the same schedule, with the result that it actually ended up being introduced years after they first talked about it, and their cultures didn't work the same way. Udo, do you want to get in on this question? I think you have an opinion here.
Oh, absolutely. No. And I think what Martin said is pretty much what we see here as well. I think this is really about, if you want to manage this whole thing, you need to choose the right partner. There is no doubt about this. And I think there are some important watch outs here. But I think the key part is you need to change the way you're working together with your partner. So what is always to me impressive, if I take a typical battery assembly line, on that line, you're producing every year batteries that have a value of roughly $1 billion. And then somebody starts hammering you on 2 million or 5 million on the purchasing price. But I think this is not where the whole thing is. This might be the most expensive saving of your life. I think that the trick is, how do you work together with this partner to save 3 or 5 or 10% of your total battery costs? Because that saves you 30, 50 or 100 million US dollars a year. So, and with this, you need to have a totally different way. And we have made great experiences is when our people are actually almost embedded in the design teams of the customer. When we understand what changes are on the horizon when it comes to your batteries, how can we actually design a line for flexibility? How can we actually produce the parts later on in a good way? So how do we bring things like design for manufacturing into your design process? So I think that really is a super important aspect. It's a different way of cooperation. RFQ will not fix this. You need to partner, you need to be embedded, you need to be involved. Otherwise, you're gonna lose a lot of money. And I think the last thing is you need to choose your partner now. The industry is heating up. Suppliers are getting super busy. There will be a time when you might struggle to find enough capacity to get all your production equipment. So selecting the right strategic partners that help you on the journey, that are committed, that get the job done on time, to my mind, becomes more and more important here.
And also probably ensuring that they actually have the capacity they say they have. That's going to be very important. Robert, do you want to weigh in on this too?
Definitely, I'm right in the middle of it. I think it's super important to choose a supplier partner that is as technologically advanced as you are, but also stable, which is quite difficult to find these days. You want a process line that is very agile and flexible, and therefore, you want your partners to be able to have an agile, flexible line. So like, for example, making interconnects, a lot of tooling can be involved potentially. And so then your design, you choose this tooling, and sometimes these tools cost $500,000, and oftentimes, and even more for one single design. But that design for sure will have some changes, and so you'll have tool mods. So it's super important that you choose a supplier that is more flexible, that can usher you into production without just throwing in a bunch of tooling and making you make decisions in the beginning, and then you're in a tough spot when you have to change something, because for sure you're going to change something. So I think that was my approach. I think that should be the approach of all integrators, is to how to supply more capability and how to work with your customer to be able to help them. And so understanding the customer's intent for the price point, the non-cell cost, as well as what they're trying to get to, their design, that's super important so you guys can level the playing field and actually play on the same team and win this thing. It's a difficult challenge for sure.
Jim, sorry, just to jump in there, you made a really interesting point I'd like to pick up. You said something, you said, and make sure you pick the supplier that has the capacity. And I think that's the real rub, and where Udo started. There isn't the capacity, just to be clear. There are not millions of factories out there. And this is part of the problem I see every day. You've got the OE saying, well, we might source our business with you. And the companies are going, great. You let me know when you're sure you're going to source it with me, and I'll spend 20 million, 100 million, whatever, putting the capacity in. Oh, but by the way, I can't put it in until you make that commitment. So you have a little bit of this chicken and egg where...
Chicken and egg, totally.
It goes back to that partnership thing. I'm going to commit to you that we're going to work together to bring this to reality. And in return, you're going to commit to start putting flexible capacity in that's going to join us on that journey. We've got to somehow break this vicious cycle that we're in. So because the capacity is not there. So
that's if you look at this, Martin, and thanks for bringing this up. In the next 2.5 years, we will somehow need to build everything between 150 and 250 battery assembly lines. One of these lines can take up to 200,000 square feet on your factory floor and sits there for 40 weeks. This capacity isn't there if we try to attack this problem the way how we have done it so far. We need to really change the game here. Otherwise, there will be no chance that we will be able to support production of 12 million electric cars in 2025.
And more in 2030. I mean, it just keeps going up rather steeply. I have some questions I think maybe have short answers. And one of them is where battery technology is going. And I wanted to reference a report that came out yesterday from ID Tech X in England that basically says we're looking at 600-mile electric cars by 2025. And I thought maybe you could give like almost one-word answers to whether that's actually realistic. I mean, we were talking earlier, and there's a question of whether they would actually be in cars or they might be on the drawing board. And on the drawing board, I'm sure, but actually in cars that customers can buy by 2025. Udo, what do you think? Quick answer to that. Maybe.
And if solid state kicks in, we start producing the same assembly lines over and over again.
Robert, what do you think? 600 miles feasible 2025? I mean, it's not very far from now.
I'll take you back on Udo. I think, yeah, it's heavily reliant on the new energy density cells and, increasing energy density with the exotic technologies like solid states or silicon anodes. But those types of technologies they have significant hurdles. You're basically starting to nano engineer the active materials. So,
but aren't we looking at
a little difficult?
You maybe have to ask the basic question is, do we need 600-mile electric cars? That's more range than most gas cars have. Some hybrid cars have that kind of range. It means we have to put really big batteries in cars that are expensive and heavy and all that. So maybe we don't need 600 miles.
You always need more batteries.
Martin, what do you think? 600 miles?
Well, I think back to my earlier point about the very mature industry that automotive generally is. If there's a 600-mile battery that a consumer can buy in 2025, I would question why they put the announcement out yesterday. It should have been a year ago, because that battery, if it's going into production 2025, has been for some time being developed and designed. And as Robert said, A sample, B samples. So I'm going to have to say, in a development mule, quite possibly. In a car you can go out and buy, I'd be surprised. But I like being surprised, so I won't discount it.
Yeah, you need a big, huge skateboard, and you'd have to fill every single spot up with the highest energy dense cell, and then still pass the safety testing there.
Well, we have companies like Lucid. Lucid says that the highest iteration of its Lucid Air will have 517-mile range, and that's supposed to go on sale. But, you know, Lucid hasn't let anyone drive its cars yet, and we'll have to see if that really does in the real world get to that kind of range. I mean, that's very impressive, but it isn't proven yet. Let me ask this. We got this in the Q&A, and please do send questions if you have questions via the Q&A button on the bottom of your screen. Will we have the electric generation capacity to charge up all these cars? Again, our subject is really batteries, so we don't have to go into that heavily, but again, you can give me a very short answer. Robert, you're on the screen, so you might as well answer that.
Certainly. So yes, I think I was surprised to see how Tesla's supercharging network came up so fast. But yes, a supercharger can come up faster than a car design, apparently. And I think there's a lot of companies working on this problem, and it's being subsidized now. So I think it's a big thing that needs to occur. I think charging, the cool thing about charging is it can happen it's more flexible than, say, going to the gas station. So you can charge at your office, you can charge at your home, you can charge at, you know, many different locations. And charging technologies are improving all the time. Right now they're connector based, and one day they'll be wireless charging. That'll be a great day. Yes, I do think that I don't think that will be the short end of the stick. I think a lot of it will be, again, related to the battery itself, the cell itself.
Udo, do you think that the electric utilities will be able to, and they are quite confident that they can handle this, but this addition to the grid, will they be able to meet the challenge?
I don't know if I'm the right one who is positioned to answer this question. What I'm seeing is, and I think this is one of the key drivers to make electric cars really meaningful, there is more focus on getting the energy from renewables. And with renewables, storing energy is not what the power supply has been built for. So what we're now seeing evolving, and that's competing a little bit, we're now seeing a number of companies coming up in, for example, the grid battery space. So the interesting thing is we have not only a dramatic demand around e-mobility that consumes a heck of a lot of batteries, we also have other fields growing like grid batteries to support power supply, etc., that take up resources and that all need these batteries. And that is not making life easier. That is making life even a little bit more challenging.
Let me ask another question from our Q&A viewers. They want to know about solid state batteries, and there's been a lot of talk about them. A lot of the development is still basically on the computer screen. It's theoretical. We don't actually even have any solid state packs that are automotive grade that I've ever heard of, but we're getting these bold predictions from some of these startup solid state companies about what they're going to be able to deliver, and actually deliver fairly soon. Udo, are you seeing solid state moving quickly so that it'll actually be in cars anytime soon?
I would say optimistic predictions say possibly 2025, and we get involved in some conversations around how would battery solutions look like for solid state. At the moment, more on the, call it, process evaluation phase, on the early pilot evaluation phase. So there is some dynamic there. There are more people putting more money into it, and this could definitely be a very, very interesting breakthrough, changing quite a lot of aspects, including the weight of the battery, what is a big driver. And at the
And
same
safety too, right? It's supposed to be safer. It's not, battery fires would be a thing of the past.
Absolutely. And at the same time, I think that's another watch out. We don't want to start building in 2025, 2026, the whole production capacity for the 12 million batteries we have in place by then from scratch. We need to build these assembly lines now already with a view, how on earth will we be able to flexibly adjust so that if a technology change comes, we're able to build on what's already installed.
Interesting. Martin, do you want to address this also? Are you looking at solid state?
Indirectly. So the interesting thing for us, Jim, is historically our markets are always niche. So whether it's aerospace, defense, automotive, but it means we're typically the smaller volumes, which means typically we're the higher performance where innovative technology gets cascaded through. So whether it's sports cars or, you know, e-turbines potentially going into VTOL vehicles and things like that. So I think if it does show its face, it will be in these premium applications, lower volume, where they'll go through a certain level of validation. I think that kind of business model has worked very effectively over the years in automotive, where, you know, it's always the lower volumes, the higher performance, higher price tag vehicles that get the guinea pig technology, if you like, passed through. So if it is coming, I would be looking to those sectors to see it show its face first.
Robert, I was wondering, when you were at Tesla, I was wondering if Tesla was looking at solid state batteries and if you're looking at it in your own company.
Well, not sure how much I can say about that, but I think I think for sure every company is looking for you know, all of the different cell types, and they're all aware of all the different cell types. But when it comes to scaling, you go to the main guys that can actually, that have the capacity in the lines, they have the ability to make good quality product. So like, I think what I see is a lot of the companies that are entering into the market right now and producing saleable product right now, they are very focused on cost, the cost story and the reliability and quality of those batteries, as well as the energy density. So they're looking at what is important today and whether that can evolve into something else. And I think the current technologies can certainly evolve as the anodes, you know, get more exotic. You know, as you're able to you know, reduce costs. I think that's a stable path towards this. Of course, there's the mythical goal of solid state that everybody always wants, but they have significant challenges, and not just cycling once, but, you know, many times, thousands of times, and not having dendritic formations that, you know, penetrate and short the cell. These are challenging problems, and it's the reason why your energy density does increase over time. But even if you solve one of these problems, it still takes time. Like Martin was saying, it takes time to vet them and make sure there's no other issues with them. So it's important to stabilize as we head into this new market. And then when new technologies happen, as Martin was saying, we have to have a place where they can go, where they can get developed and evolved correctly and fast. And so the premium markets are definitely a great market for that. And that was kind of the way that Tesla started out with the Roadster. The Roadster was a premium product and it could do all these awesome things. And that's why people bought the car. It wasn't just because it was an EV. It's not like a golf cart. So so that kind of ushered in to the Model S and then to the Model 3 and to this next, you know, Model E, next car. So there's that evolution that needs to occur.
Udo, we look at the question of these battery lines, getting back to sort of the central question we're talking about here today. Is there anything they can do, automakers and their suppliers, to sort of future-proof their lines so we don't have some of the problems you're talking about?
Well, I think I personally don't believe that there will be a large level of standardization in the industry, which would definitely make life easier. I think there might be a kind of modularization of products at car makers for different type of cars they're using. There, I think there is a huge opportunity. But I'm coming back to that piece of, on the one side, include your automation partner in your design activity to drive design for manufacturing, design for flexibility. The other piece is really trust your automation partner on their spec. I think automation partners that have done a number of challenging projects, they know, for example, what good laser welding looks like. They know, for example, how you can overcome tolerances in your cells that in certain applications don't work. They also realize that, hey, you're moving your specification from a powertrain application over to battery. And I see OEMs that are measuring 700 data points on a battery assembly line and get no insight on how can they improve uptime, availability, and all such things. So I think that close cooperation, partnership, strategic cooperation, involvement, and trust that somebody who has proven that they can execute such stuff successfully, sometimes know a little bit better what good looks like. I think that type of cooperation and close partnership is what can help in the current environment.
We only have a couple minutes left, and a number of people have asked about swappable batteries, and that's been tried by companies like Better Place in Israel, not very successfully, but it keeps coming up. Maybe you can just give very quick answers, a couple words. Swappable batteries, are we going to see those? I don't personally see it happening, but what do you think? Robert, why don't you take that? Swappable batteries?
Yes, I think this is something that's very interesting that a lot of companies try to approach. I've seen it at Tesla too. And the problem is your connector has to be very robust and it has to handle all the cycles. So I think that's a significant challenge. I think it's an unnecessary challenge. I don't really believe in swappable batteries at this point, but.
Well, let me stop you there. Martin, what do you think? Swappable batteries? Yes,
yeah,
or
I
no?
won't go into all the reasons why I don't think, but I think there's a whole range of reasons that they're probably not the answer. So I'm with Robert on this. I think, yeah, you see the innovation in charging times. If you plot the graph, it won't be long before the chargers will charge faster than you swap the batteries. So yeah, I'm with Robert on this one.
Brenda, I see you popping up. Does this mean we're out of time?
Yes. Maybe if Udo wants to give his last comment on that.
I think everything has been said. My opinion, mainstream swappable will not happen. Niche applications, yes. NIO is great on that, but that's about it.
Okay, thank you very much. Thank you very much, Jim, and thanks everybody for joining us today. It was a fantastic conversation. We had lots of questions, and I hope you enjoyed this discussion today. I will send the recordings afterwards, probably in tomorrow. And enjoy the rest of your day or evening, and see you next time for more Reuters events.
It was very stimulating. I learned a lot from you panelists. Thank you, Martin. Thank you, Udo. Thank you, Robert.
Thank you.
Thank you, Brenda.
Thank you, Jim and Brenda. Thank you.
Thank you, Brenda.
Thanks, everyone.
Okay.
Bye-bye.